Assalamu alaikum, dear students. I am Ms. Sada Bahar, a physics teacher, in Senior Girls Wing, teaching you physics, on behalf of Pakistan International School Doha, Qatar. Well dear, as we have started Unit 10, of Grade 10, Physics, and, in our previous lessons, we have done topics till example 10.1, now, to proceed further, today, we will do these topics. Damped oscillation. Wave motion. Types of waves. Types of mechanical wave. Wave as energy carrier. Wave equation V equals F lambda. Dear students, before taking proper start of our today's lesson, first of all, learning objectives. Learning objectives. At the end of the lesson, students should be able to describe damped oscillation. Define and explain wave and wave motion. List different types of waves. Differentiate between longitudinal and transverse waves. Describe waves as energy carrier. Derive the formula. V equals F lambda. Damped oscillation. The oscillations of a system in the presence of some resistive force are damped oscillations. Explanation. Vibratory motion of ideal systems in the absence of any friction or resistance continues indefinitely, under the action of a restoring force. Practically, in all systems, the force of friction retards the motion, so the systems do not oscillate indefinitely. The friction reduces the mechanical energy of the system. As time passes, and the motion is said to be damped, this damping progressively reduces the amplitude of the vibration of motion. Application. Shock absorbers in automobiles are one practical application of damped motion. A shock absorber consists of a piston moving through a liquid such as oil. The upper part of the shock absorber is firmly attached to the body of the car. When the car travels over a bump on the road, the car may vibrate violently. The shock absorbers damp these vibrations and convert their energy into heat energy of the oil. Dear students, now I will tell you about wave and wave motion. Question: what is wave and wave motion? Explain wave motion with the help of an experiment. Answer: wave. A wave is the disturbance in a medium which cause the particle of the medium to undergo vibratory motion about their mean position in equal interval of time. Wave motion, it is the transfer of energy from one point of the medium to another point of the medium without actual transport of matter between 2 points. Experiment: dip one end of a pencil into a tub of water and move it up and down vertically, as shown in figure. The disturbance, in the form of ripples, produces water waves, which move away from the source. When the wave reaches a small piece of cork floating near the disturbance, it moves up and down about its original position while the wave will travel outwards. The net displacement of the cork is zero. The cork repeats its vibratory motion about its mean position. Dear students, now we will discuss different types of waves. Question: what is wave? Describe different types of waves. Answer: wave. A wave is the disturbance in a medium which cause the particle of the medium to undergo vibratory motion about their mean position in equal interval of time. Types of waves. There are two categories of waves. 1. Mechanical waves. 2. Electromagnetic waves. Mechanical waves, waves which require any medium for their propagation, are called mechanical waves. Examples: water waves, sound waves, waves produced on the strings and springs. Electromagnetic waves, waves which do not require any medium for their propagation, are called electromagnetic waves. Examples: radio waves, television waves, X-rays, heat and light waves. Types of mechanical waves. There are two types of mechanical waves. 1. Longitudinal waves. In longitudinal waves, the particles of the medium move back and forth along the direction of propagation of wave. Explanation: longitudinal waves can be produced on a spring, slinky, placed on a smooth floor or a long bench. Fix one end of the slinky with a rigid support and hold the other end into your hand. Now give it a regular push and pull quickly in the direction of its length. A series of disturbances in the form of waves will start moving along the length of the slinky. Such a wave consists of regions called compressions, where the loops of the spring are close together, alternating with regions called rarefactions, expansions, where the loops are spaced apart. The distance between two consecutive compressions is called wavelength. The compressions and rarefactions move back and forth along the direction of motion of the wave. Such a wave is called longitudinal wave. 2. Transverse waves. In case of transverse waves, the vibratory motion of particles of the medium is perpendicular to the direction of propagation of waves. Explanation: we can produce transverse waves with the help of a slinky. Stretch out a slinky along a smooth floor with one end fixed. Grasp the other end of the slinky and move it up and down quickly. A wave in the form of alternate crests and troughs will start traveling towards the fixed end. The crests are the highest points while the troughs are the lowest points of the particles of the medium from the mean position. The distance between two consecutive crests or troughs is called wavelength. The crests and troughs move perpendicular to the direction of the wave. Examples: light waves, waves on the surface of water are the examples of transverse waves. Dear students, now I will explain the topic, waves as energy carrier. Question: waves are the means of energy transfer, without transfer of matter. Justify the statement with the help of an experiment. Answers: energy can be transferred from one place to another through waves. For example, when we shake the stretched string, up and down, we provide our muscular energy to the string. As a result, a set of waves can be seen traveling along the string. The vibrating force from the hand disturbs the particles of the string and sets them in motion. These particles then transfer their energy to the adjacent particles in the string. Energy is thus transferred from one place of the medium to the other in the form of wave. Now the topic is explained with the help of water waves. Water waves also transfer energy from one place to another as explained below. Experiment: drop a stone into a pond of water. Water waves will be produced on the surface of water and will travel outwards. Place a cork at some distance from the falling stone. When waves reach the cork, it will move up and down along with the motion of the water particles, by getting energy from the waves. Conclusion: this experiment shows that water waves, like other waves, transfer energy from one place to another, without transferring matter, that is, water. Question: derive the relation between speed, frequency and wavelength of waves. Wave equation. Answer: wave equation. The relation between speed, frequency and wavelength of waves is called wave equation. Derivation: wave is a disturbance in a medium which travels from one place to another and hence has a specific velocity of traveling. This is called the velocity of wave, which is defined by velocity is equal to distance divided by time, or v is equal to d divided by t. If time taken by the wave in moving from one point to another is equal to its time period t, then the distance covered by the wave will be equal to one wavelength, lambda. Hence equation 1 become v is equal to lambda divided by time period, since f is equal to 1 divided by time period. Therefore, v is equal to f lambda. This is called wave equation. Dear students, at the end I would say stay safe. Thanks.